my research focused on evaluating the effects of legacy phosphorus on soluble phosphorus losses in tile drained systems. And the reason for this focus is the farmers in the Midwest United States have over many decades depended on anthropogenic phosphorus inputs to meet the growing food and energy demand. And the result has been this accumulation of phosphorus in those agricultural soils, leading to the saturation of phosphorus sorption sites. And this means that once these sorption sites are saturated, any additional P will most likely remain in the soil solution phase. And as a result, this added P is more susceptible to losses in either leachate or in runoff. And so my research was able to develop and validate two phosphorus sorption capacity-based environmental indices, which can be determined on a routine basis and used by farmers to determine which soils were acting as phosphorus sources and which soils were acting as phosphorus sinks. And with this, they would be able to decide on whether to add more phosphorus or to avoid any further application of phosphorus. So we used artificial neural networks to improve the predictive performance of the phosphorus index. And first of all, the phosphorus index is a field scale assessment tool used to identify critical source areas of phosphorus loss. And as such, it is composed of different site characteristics, P source and transport site characteristics, which are weighted depending on the magnitude they have on eventual phosphorus loss from a field. Now, when we look at the existing phosphorus indices in different states in the United States, the weights assigned to the different site characteristics were usually based on professional judgment, which is another way of saying best guesses. And for those, and in some other states, they took weights from neighboring states and adapted them to the indices in their state. And for very few phosphorus indices, they used measured data to determine the weights for the different site characteristics. So in all these cases, you find that the real world interdependence between the different site characteristics were not considered when determining the weights. And this is why we decided to use artificial intelligence to model soluble phosphorus losses in tile drain systems. And then once we built up our model, we used relative importance algorithms to give us the weights of the different site characteristics. And when we used these neural network generated weights and put them in an index and then compare the performance of that index to existing indices, we found that the performance was greatly improved with the relationship between PI values and soluble phosphorus losses being better predicted. There are many strategies which can be used, and these best management practices can either be in-field or edge of field. For in-field, the best starting point is always the 4 R's of phosphorus management. right source, right rate, right placement, and right timing. And you can include other management practices such as the use of soil amendments such as gypsum or rhizosob, which is one of the technologies part of the research team working on it now. You can have edge of field structures, buffers, strips, but the key thing is to first understand your field before you decide on the best management practice to undertake. My research interests lie in food and water security, and so it does not come as a surprise that I'm a research scientist here at Phospholutions, where our focus is on sustainable phosphorus management, working to develop technology that can that promotes efficient use of phosphorus fertilizers. So that's basically where my research interests lie, because number one, we get to manage this resource, which if you think about phosphate rock, it's a finite resource. So there's really an urgent need to start utilizing phosphorus fertilizers in a sustainable manner. And then when we look at the recurring eutrophication cases in a lot of surface waters in the United States and also in Europe and China, there is an urgent need for us to control the phosphorus that we are losing from fields. And this is really the focus of my research.